Well, good afternoon and welcome to DistribuTECH in Orlando, Florida. We are here live with this webinar about the San Diego floods and underground system resiliency. With me today is Lynette Aquino from San Diego Gas and Electric. She is the program manager of strategic undergrounding. Lynette, welcome, glad you're here. A couple of words of welcome to the audience.
Thank you for having me here. Well, I work for San Diego Gas and Electric, and I serve as the program manager for our strategic undergrounding program. It's one of our wildfire mitigation plan, which includes several initiatives that we have, and strategic undergrounding program is one of them. The aim of the program is basically to remove or reduce wildfire risk and the use of power shutoff when we experience those red flag season or adverse weather condition. So I'm happy to be here.
Yeah, we're excited to have you. Thanks for coming. Also with us is Ben Lanz. Ben is a director at IMCORP, and he'll be our subject matter expert today on cables and what cables look like when they're underwater, which apparently they were in a very big way in San Diego. Ben, a couple of words of welcome to the audience.
Sure, thanks Mike, and welcome everyone. This is live, right? We got the whole background noise and everything, but hopefully you can hear us quite clearly. We're really excited to be here. We're talking about reliability. We're talking about reliability in flooding, and I'm happy to be a part of this panel.
Yeah, well good. We're happy to have you. This is brought to you by IMCORP and the Power Delivery Intelligence Initiative, PDI Squared. It's a group of contractors and consultants and vendors and equipment manufacturers that advocate for underground and the total cost of ownership over the life of the asset. And so when these massive floods happened, Lynette, back in January of this year, you and I were talking, we're getting ready for what we did today with here at DistribuTECH with our underground panel. And we were talking about, well, what happened to the underground system at San Diego Gas and Electric when you had what was called by some the 1,000-year flood event. So, okay, what if it wasn't a 1,000-year flood event? Even if it was the 500-year flood event, it was massive. I remember seeing pictures of cars floating down drainage ways. Tijuana, Mexico dumped millions of gallons of sewage into Coronado Bay. I saw I-5 had a big old puddle in downtown San Diego. So it was pretty significant. And I said, we should talk about that. And so you agreed to come on and do it today. So we're interested in hearing your perspective and then how the system responded. So I guess I would say with that little introduction and a little bit of background, Lynette, why don't you give us some of your thoughts about the system reliability in this last big flood, what you're doing with the underground program. We know a lot of undergrounding at San Diego Gas and Electric has to do with wildfires, but just underground in general would be really interesting to hear from you with some opening remarks about that.
Yeah, in general, our system held quite well. We didn't really have a lot of outages. Generally, most of the flooding that took place are more on the metro region of our facilities. But in terms of outages for the newly installed underground facilities that we have, we didn't really have any of those outages. But there's some equipment that were affected during the flooding. But these are equipment that we're talking about that has been installed 30, 40 years ago that were affected. And so these are bare wire connected, like fuses and terminators and all that. But in general, all our underground facilities that we had installed in the last 20 years had maintained the way we service. You provided a picture I think in one of the slides that you were showing there, that you can see even that mass flooding that you can see the street lights still working during those times. That tells you that our underground facilities are operational and working.
Right. So any other comments before we turn it over to Ben to make some comments about what his observations have been with cable and cable life and monitoring cable?
Well, the cable life are most of the time submerged underground, right?
Right.
They're subject to that type of condition. Most of the time when when we maintain them, we see a lot of in the vaults itself, there's a lot of water in regular rain before we can even maintain those. So they sustain that type of environment and condition in a regular basis, whether it's a high amount of water flooding versus regular rain.
Right. High water tables in coastal cities, many times those manholes are going to be full of water, and you're going to have to pump those manholes out before. So we're used to having equipment, and as we're going to transition to you, Ben, we're used to having equipment in manholes that is submerged.
Yes.
And it operates very well and very effectively today in 2024. Now going back maybe 40, 50 years ago, if some of that antiquated equipment could suffer, I don't know. Ben, what do you think about that?
Yeah, I think it's really interesting that you said that the only outages you had were those open air insulated components, which is what we would expect, right? If you have water that's coming in contact with a live conductor, you're going to get a short. But as you pointed out, these systems live underwater a good portion of their life. And in fact, in the Power Delivery Intelligence Guide for Life Cycle Cost Evaluation, which just came out, we're very proud of that Power Delivery Intelligence Initiative, PDI2.com or .org, that communicates all about that. It basically says that these systems are designed to be, the new modern materials are designed to be fully submersible, and it's really not the water that's causing the failure. It's, like you said, those open air connections that are causing the problem in the flooding condition.
Yeah.
Okay, so Ben, you've got some things you want to talk to us about some of the things that IMCORP is doing before we go to audience questions. We'll go to audience questions here about the last half of this. And so be thinking of, a couple of questions have come in. One question already, Lynette, is about pad-mounted switchgear and transformers and such. And what's your experience just generally, and maybe Ben, you want to address that too, about pad-mounted equipment and how it survives in a heavily flooded environment. You want to comment on that, Ben?
Yeah, well, she already mentioned the fact that if you have a pad mount, say, transformer, the URD side of it, the medium voltage side of it, those are generally 200 amp elbows, so those are sealed. And you can get equipment that can be fully submersible. Obviously, typical pad mounts also have a low voltage side, which is bare bus. Obviously, if that comes in contact with water, that's going to short out. But there are many products that are installed even below ground, below grade, with modern technology. So I think it's certainly something that you are going to experience in a flooding condition if you have open air insulated components. But the reality is that with modern systems, we can either raise them up so that they're out of the flood zone, or we can even buy submersible style designs.
Well, why don't you go ahead and talk about some of the things you want to talk about. We do have a lot of questions coming in from the audience, so I appreciate that, audience. I will say one that just came in that's kind of interesting is, what about cover? So if we are putting things underground to solve for wildfires and to solve for a variety of things that impact the electric distribution system, is reducing the amount of cover, the standard amount of cover that we might require, is that going to exacerbate the problem? Is it going to add to the problems? Or some would actually talk about laying underground, not underground, but on the surface and protecting it on the surface even. So you want to comment about cover on underground just briefly?
You mean like
Ben?
depth of burial?
Depth of burial, yes.
Okay. Do you want to say some things about that?
I can touch on the strategically positioning the equipment on a certain position, so that way, because we also study the flow of water during when we're doing our design. And so we can strategically put the equipment where it's not prone to like flooding. But again, the vault underneath, it's always going to be subject to water all the time. And if we're talking about just like switches, pad mount terminators, I'm more worried about like car hitting those than water, to be honest with you.
In fact, you said that it happened, right? There were some vehicles or something that was like a battering ram, I think you said, right?
At one of the Terminators.
One of the Terminators, right. So it actually, but as far as burial is concerned, we actually just had that question come through to Power Delivery Intelligence Initiative as to how do the systems survive under wildfire conditions, and the reality is the Australian bushfire example shows us that as soon as you get below grade a little bit, most of the heat is above, and the cables themselves survive very well. So I don't know if, I think that was the question, but that was one.
That was generally the question.
Okay.
Generally the question. So do you have some things you want to share with some slides and things like that?
Well, yeah, I'd like to actually mention, it's interesting to think about, okay, so if cable systems don't fail, by and large, during floods, so when do they fail? And you could advance the one slide there that shows what we call the 10 root cause categories of cable system failure. And what you can see is that there's two categories, basically a lack of insulation that's supposed to be there, we call that a void. So that could be damage, could be a manufacturing defect, it could be some overheating connectors that blister material, could be damage from the outside due to chemical attack and so forth. There's another category called stress enhancements, which are focuses of electric stress. It's like the proverbial needle, so like a nail stuck in the cable. There's such a high stress it can break insulation down directly. And in either of these cases, there is an erosion process that takes place over time, which has almost nothing to do with water. Water can be a precursor. If you have concentrated water in a small area next to a dry area, you can get on a termination, you can get what called dry banding. So you can get focuses of electric stress due to moisture, but moisture and water itself, I think it was stated once that 4 feet below ground, anywhere in the world, is 100% moisture. So these systems live in high moisture and under the water most of the time. So it's really those physical defects that we install during installation. In fact, about 40% of new installs will have at least one substandard component. And then those defects don't fail because it's an erosion process that takes time for many years sometimes. Sometimes it's short, but sometimes it could be decades. And that's really the aha moment that, okay, if they're not failing because of water, how are they failing? And the predominant failure is because of the impact we humans are having on these systems, damaging them on the way in or perhaps during their lifetime.
Yeah, you and I have talked before, Ben. I personally advocate for putting those kinds of early tests into the specifications that engineers are writing today for new cable installations. You're going to install a new cable, you get it from the manufacturer, you know the condition that it comes in, your contractor or your utility crew installs it, test it again by specification, test it again, make sure you know the baseline condition of it, and then you've got some place to go from there. Now, assuming that you operate that within the parameters of the cable specifications and the cable design, that cable ought to be good for decades of time. Would you agree with that? Did I state that correctly?
That was very well stated. In fact, in our new guide, Power Delivery Intelligence Initiative guide, there's claims actually in the industry up to 100 years of life that these assets. I know that We Energies is saying 60 years to their Public Utility Commission, so the reality is the materials aren't going to fall apart. But if we can eliminate the defects and, like you said, operate it within normal parameters, not extreme loading, right. Keep it well protected from overvoltage protection, no dig-ins, mechanical protection, the system's going to survive.
So Lynette, today we did a panel session, and you tell me 100 years, Ben, okay, that's a lot, and I'm not going to be around to make sure that you're right on that. Right. But what if you're half right? So 50 years of life. We heard today 44 years of life at Beaches Energy, which is in Jacksonville Beach. So it's a coastal area, high water table. They sustain hurricanes and floods and stuff, probably of the same nature that you had in San Diego. So 44 years of life. You probably are seeing the same kinds of things. And I would bet there's an expectation of the new strategic undergrounding that you're putting in at San Diego Gas and Electric, that it lasts 30, 40, 50 years. Would that be a fair assessment?
Yeah, that's a fair assessment. I mean, generally, most of us are using the same type of cable, and there's not a lot of cable manufacturer there that we kind of go with the same one that that we trust, right? And we have relationship with. Yeah, generally they last 40, 45 years or even longer. I don't know about the 100 years because I have not seen one that I have installed. Like
sure.
I'm new into this realm of undergrounding, but I would love to see all the undergrounding that we had performed in the last 4 years for the wildfire initiative effort stay 100 years. That's why that guy, what's his name, he says, you set it and you forget it. What's his name, Matt?
Yeah, Matt Seeley today was on the panel from Beaches Energy, and he basically said you put cable in conduit, and you do a good job, and you don't damage the cable during installation. You put it in there, you set it, and forget it, right? And he did have decades of experience there. The other cool thing about the panel that we had today, that you were on, Lynette, was we had some experience from a gentleman who came from Colorado Springs Utilities, then at Fort Collins, and now currently at City of Loveland. And up to 90% of their distribution system at those three utilities, and even some of their transmission system, is underground. And they've had a tremendous success rate after decades of being dedicated to undergrounding their T&D assets. So that was Craig Batter today at the panel. We had a great panel today here at DistribuTECH. Again, we're coming to you live from DistribuTECH. We thought you'd be interested in knowing that there's some good things happening at DistribuTECH. There's 17,000 people here, probably 6,000 or 7,000 of them are utility personnel, and the rest are vendors that want to sell to utility personnel, right? And anyway, so a lot of good education going here, and I was actually struck yesterday, I posted this on LinkedIn, Lynette, one of the keynotes was a futurist that was talking about the future and the impacts of artificial intelligence and such. And so it's a good event, and we appreciate certainly being here. Ben, so you're the subject matter expert on cable, and you agree with me, and I know we've talked about this before, about the need for young engineers that are writing new specifications, standards engineers that are writing new specifications to put this kind of language into their specs. How would you advise somebody to do that?
Yeah, it's actually quite simple. And again, I go back to the PDI2.org guide there. It's all in there. We've collected all these best practices from utilities all across the country. And it's about a 9-word specification. It's an offline 50 or 60 hertz PD test with 5 PC sensitivity. That is the specification that gets you the manufacturer's spec. So wouldn't it be great if it's tested in the factory from your favorite supplier, and then it's repeat tested in the field. So now we know we have the same product, same quality, which we know these assets can live much longer if they're not installed with issues. So that's a great opportunity to put that specification in there. I also want to specify, there's all sorts of great points in that guide. They talk about shear bolt connectors for connections to minimize bad connections, and different types of insulation that have a longevity that actually compensate for some of the challenges that are in the field. So really a lot of if you're looking for ideas about new specifications, that guide is a great place to start.
Yeah, good. Here is a question from the audience, and keep those questions coming in, we certainly appreciate them. How does IMCORP actually detect the flaws? Just give us the 30,000 foot level description of your technology. I know you say you like to liken it to an MRI for cable, but
yeah, for the layperson, I call it the MRI of underground power cable. It doesn't work like an MRI, but in a sense, you're getting a scan, right? You're getting a foot-by-foot profile of the asset so that you can determine what's going on under the ground or wherever that cable may go. But in essence, you're looking, if you're familiar with fault locating, very often during a fault location, you're using time, distance, and the echo time of signals. And in essence, we're talking about a fault signal that's about 1 million times smaller. So it's very small, well below the background noise that's typically that it typically occurs in the field. And the trick is to be able to efficiently couple to the cable system and eliminate the background noise and bring the system up on voltage for a few seconds to observe, are any of these little micro arcing locations, any of them exist? And then compare that performance against what you received from the manufacturer. And you should see the same performance. And if you don't, obviously, most likely, we as humans have probably damaged the system. So that's the whole idea, is to be able to locate those micro arcing events we call partial discharge in the cable systems and remove those, ideally during the capital investment process as opposed to waiting for them to fail under O&M.
Yeah. We're going to shift to you and ask you about your program that you're doing on strategic undergrounding, but here's just a general question, and Lynette, I'm going to give this to you as well, but this is a question from the audience about, well, why not just make a bigger storm sewer system in San Diego if you know you've got these flooding issues, if flooding is becoming more and more apparent? And my recollection is San Diego doesn't have much of a storm sewer system. I know on Coronado Island they don't have much. They just have roads that allow drainage because it's really a desert and it doesn't rain that much. This rain that you had in January was a real anomaly. Is that true? And then just comment on that. I mean, it's funny to say that we as the electric utilities will go and impact the size of the storm drain, but
from the utility side, I can't comment on the utility drain. That's more for the city to respond to that. I think they have a lot of questions. The community has a lot of questions as to why our storm drains didn't work appropriately. But from the utility side and from the wildfire situation side is that we don't have that responsibility to create drains for. What we're looking for is that the impact of the utility to the community, and what we're trying to accomplish in the wildfire effort is to reduce the wildfire risk so that we continue to serve our community and our customers in the most reliable way and in the safest way. And I have found that 99.9% the undergrounding is effective in that type, when you subject it in that type of environment. And we have seen it during that flood that it stays reliable to serve our customer.
Right, so that would be not only reliable, but in a case of a high impact, low probability event like this massive flood that you had in San Diego, that would be called resilient. Your system was resilient in the face of something that was extraordinary, so that's good. And while reliability is measured in minutes, resiliency is measured in days, and you could have had an outage there that could have lasted 4 days, theoretically, with a 1,000-year flood event. So anyway, so that's good to know, and I think, Ben, that this is one of the things that we want to convey about underground is reliable and resilient in the face of these major storms. A flood is one event, but ice storms and hurricanes and tornadoes and these other things that take down our overhead system. Only about 18 to 20% of the system in the country, in the United States, is underground. The rest of it's overhead. And you can go to some major cities that have not started to embrace undergrounding yet, and everything's overhead. And they have their reasons for that. Not necessarily good reasons, but that's debatable. But anyway, Lynette, I want to shift back to you and tell us a little bit about the program that you're doing. So you're doing a really cool program. It is wildfire related. I want to focus on the underground portion, but I know that you're doing other emerging technologies at San Diego Gas and Electric. I know that you're looking at covered conductor for a quick impact. I know Southern Cal Edison's doing that as well. But with the underground in particular, how are you executing the program? Are you hiring consultants? Do you have contractors? Did you build a team? Were you able to select your team and build the team from men and women around the organization that you knew that you could trust to get this major initiative done?
Yeah, this is a major effort and really provide a great benefit. So the way we started the program is only about 4 years old. We started in 2019. And we really piloted a a small undergrounding project, and we basically started with targeting critical facilities in the backcountry area, and most of our undergrounding conversion related to wildfire risks are in the backcountry area, because that's where our fire risk prone circuits are. And so what we did is that we invested in, we work partners with our existing contractors while also working with our subject matter expert internally. But later on, we realized this is an effort that's becoming massive, that we are embarking. And so we had RFP the whole entire program about 2 years ago. And we had partnered with AECOM to bring in the program management, the engineering design,
right.
the procurement, and later on we're going to RFP the construction portion of it. But we had partnered with AECOM to help us lead the effort in helping us with resources. As you know, that this is going to be until 2031, our goal is to underground approximately 1,500 miles total as part of our goal. And so we're embarking in this journey, and we need good partnership, and we had selected AECOM as our partner.
Yeah, good partners make a big difference. Did you tweak your standards at all for underground in preparation? You know, you knew I was probably going to ask you that.
Yes, we had to, right? So, as you guys know, that undergrounding is really, it's expensive. I'm just going to say it, I'm a straight shooter. But we had to find ways as to how we can reduce costs. So over the course of 4 years that we've been doing this, we had reduced by over 60% of our initial costs. And
wow.
Yes, and so the way we did that is that we had to tweak our standards, and specifically majority of the cost is in the civil side of construction.
Right.
And so we had to change our trench cover from 30 inches trench cover to 24. You might say, hey, you know, that's only like 4-inch difference, but that 4-inch difference is gonna tell you whether we're gonna go, 6 feet, because we have utility conflicts or whatnot. And also, the less that 4-inch difference, the less you take out, the less you haul out.
Yes.
And less labor. So that's the majority of our
I think
costs.
that going back to the question that somebody asked about the cover, well, those are excellent points, that you don't have to haul it off. And sometimes when you haul off material, you have to landfill it and pay to landfill it, or put it in a place that somebody's going to accept it. Right? It doesn't necessarily go back into the trench.
No, it doesn't.
So, yeah. Good, good. Well, we're going to wrap up here, and I would just say thanks to the audience for the questions. I appreciate it. Ben, some closing remarks, if you'd like.
Well, I really appreciate, Lynette, you participating, and when we first chatted, Mike first chatted with you about this, and we heard that there was certainly impact to the neighborhoods. There were health and safety issues, there were overhead issues, but when we heard that really the underground had remained reliable, except for the open air insulated components, that's just a remarkable story. And time again, we hear across the nation how people are afraid of undergrounding, and one of the bullet points they bring up is because of floods. And here it is, not only with the survey we did with Hurricane Sandy, with Burns and Mack a couple years ago, and they had extraordinary performance. Now we're seeing it here again. I think that speaks well. And on the flip side of that, so we have the science. We understand how cable systems fail. We don't have to guess. And we have technologies that can help us so we can predict how these systems are going to perform. And I'm confident that these systems will last 40, 50, 60 years.
Or 100 even.
And some people are
Maybe
even saying 100 years.
That's right. No, and you've got some of the empirical data to support it too.
That's right.
So that's part of the beauty of what you guys do at IMCORP. So.
Right.
Lynette, bring us home. Give us some concluding remarks. We really appreciate you being here at DistribuTECH with us and being on the panel earlier today and on today's webinar. So some concluding remarks.
Thank you for the invitation and being able to provide insight from the undergrounding utility perspective. I think that undergrounding and removing wildfire risks is not just a responsibility of the utility, but I think it's a responsibility for all of us to share the knowledge and educate so that we have the right information, you know, so that others are not scared because they don't know what underground system configuration or how it sustains and all that. I think giving this forum, and I appreciate you inviting me and having this forum to talk about it.
Well, thank you so much for coming. We appreciate it as well. So thank you so much. We appreciate, audience, that you listened in today. So on behalf of IMCOR, our sponsor, and the Power Delivery Intelligence Initiative, we appreciate you being here. Thank you. And Jeff at T&D World Magazine, we hand it back to you.